Recording? I am. Who knows on the quality, but hopefully it's okay. All right, let me kill the projector. If somebody wants a pic of the board, actually, I won't take a pic of the board. What I'll do is I'll just move over the one that I did in OneNote last year for this one, and then you'll be able to see it in OneNote. Okay? All right, so I need someone to check in with on, this is Chapter 3, number 38. So Chapter 3, number 38, who can I check in with? All you have to do is have the question in front of you. Yep, I'll check in with you. All right, do you have the question in front of you? All right. And everybody tune in, have your workout just to make sure you got it right for the right reasons, okay, if you did. So it says, stones are thrown horizontally, keyword horizontally, with the same velocity from the tops of two different buildings. And I already know they're going to ask me for a ratio, so I'm immediately going to draw two pictures. And what I like to do is on a ratio problem, I like to put the variables on the picture. You could also make a list of them off to the side. And if a variable, I guess it's not much of a variable, but if the value is the same from one picture to the next, I will use the same variable. If they're different, okay, or they might be different, I'll use subscripts to denote that, okay? So here's going to be my picture of my taller building. Here's my shorter building. We're going to do something like that, okay? And I haven't really drawn this to scale other than I think we could probably figure out that if we throw it horizontally from a tall building, it's going to land further away than from the smaller building. Are you okay with that? All right. And this is just going to be Vx, and this is going to be Vx. So they have that same horizontal velocity when they're launched, okay? And that also tells us that initial velocity in the y direction for both of these will be 0. Because it's in the y direction, it's as if it's being dropped. Is that okay? All right. And now I'm going to call this will be like my case 1. So I'll call this x1, and I'll call this x2. Okay? I'll call up here t1 and t2, because if they're both being dropped in the y direction, but one's a much taller building, they will have different times to hit the ground. Is that okay? Just dropping things from different heights, different times. Okay? And if you're not sure if the variable's different, okay, for case 1 and case 2, just leave it different until you reread the question. Okay? And I'm going to call this right here y1 and y2. These are different because they said one building was taller than the other one. Okay? Now, let's see here. It says one stone lands twice as far from the base of the building from which it was thrown as the other one. So one's twice the other one. So you could leave this x1 or x2, or for this one, I'm going to do it different than the last ratio. I'm going to go ahead and take care of this right now, okay, and put this one as 2x and put this one as x. Are you okay with that? If you didn't notice that and had the x1, x2, that's fine. Eventually down the line, you'll be like, oh, I missed something in the problem. And you'll go back and you'll realize that x1 equals 2x2, that kind of a thing. I've taken care of that right here. We got 2x and x. Is that still okay? All right. Now I'm going to keep reading. It says, find the ratio of the height of the taller building to the height of the shorter building. So we are looking at this one, the ratio of this one to this one. So I am going to write y1 over y2. That's what I'm trying to figure out. So I need an equation for displacement. So how am I going to figure out which equation to use? I'm just going to do this over here. Okay? I'm going to list my 5 variables. And I'm doing the y direction because I'm looking for something with y in it. Is that okay? All right, I know we've got this link between the x direction. We'll deal with that in a little bit. So v initial, v final, time. All right, and now I'm going to look at my picture here, and I'm going to decide which equation I want based on like what's given in the picture and what I have. Well, I know the acceleration for both of them, so I'm fine with acceleration in the equation. Is that okay? All right. Vx, this is also letting me know that initial velocity in the y for both of them is 0. So I want v initial to be in my equation because it's 0. Is that all right? So I know acceleration, I know v initial. Now I need some other variable here that's going to be, that I'm going to know so that I can solve for displacement. So my choices are v final y and time. Well, v final y, I don't know for either of them. Time is the one thing that is okay because do we have some way to relate what's happening left to right between the two cases? We do. And time is shared, right? It's a scalar. The time in the x direction is the same as the time in the y direction. So I probably want time to be in my equation. That'll be a better choice than v final y. All Are you okay that time is probably going to be okay because we have something connecting them in the x direction as well? Is that all right? Okay. So now I'm going to pick my equation where I don't care about v final. So that is, yeah, this one. Y minus y naught equals v naught t plus 1/2 a t squared. And this is nice. My initial velocity in the y for both of them is, anybody? 0. So I'm going to go ahead and get rid of that. That whole thing is just 0. Is that okay? All right. And maybe you go a little further here. Maybe you're like, oh, I'll plug in the negative 9.8 times 1/2. And you'll be like, oh, it's negative 4.9. Now, if I'm going to plug in, I better put units. Negative 4.9 times t squared. That would be a general result that would be true anytime an object is dropped. Are you okay with that? That's a result anytime an object is dropped. And when I say dropped, I mean, like it's the initial velocity is 0. Is that okay? All right. So if we're in free fall and we drop something, that result is true. Now I'm going to apply it specifically to my case 1 and case 2. So this is like my general result that I can apply to both of them for this somewhat special setup. And now let's see what happens. Okay. So for y1, I'll go ahead and plug in negative 4.9 meters per second squared times, look over here, t1. Is that okay? Because we know the times are different, so I'm using the t1 over negative 4.9 meters per second squared times t2 squared. What happens to the negative 4.9s? They cancel out. And yes, you could have left them as 1/2 ay, and they would also cancel out. Okay. Anytime you're doing a ratio, if there's numbers to plug in, you might just want to hold off because there's a decent chance that they'll cancel out. Okay. Just depends on how comfortable you are with what we're doing up here. So I'm going to put equals down here, t1 squared over t2 squared. And now we're stuck. Okay. So if we're stuck and we've already looked at the y direction, and it made sense to start with the y direction because they're asking for a ratio of y1 to y2. If we're stuck in the y direction, go back, reread the question. We didn't miss anything. Now we need to look at the x direction. Okay. In the x direction, it's a free fall problem. Okay. There's no forces in the x. In fact, we didn't know this back when we did chapter 3, but if I did a free body diagram, it would just be that. Okay. So our acceleration in the x will be 0. So my equation, I'm going to put this down here. My equation is just that. This is that 50 miles per hour in your car, steady 50 miles per hour for 2 hours. How far did you go? 100 miles. That's all you need when your acceleration is 0. You've been doing it since a little kid, okay? Elementary school type math. Are you okay that this is true if the acceleration is 0? You're still with me? Okay. All right. So now let's solve this for t, because that's what we're trying to get rid of over here, right? We're trying to take care of t1 over t2. So t will just be x minus x naught over vx. Oh, and I say you don't have to show work for this usually when you're plugging in numbers, but if you're going to like derive an equation and substitute in somewhere, yeah, I'd probably write this down so that you don't accidentally do what to something. Yeah, that you don't accidentally flip it, write the reciprocal, because it's happened. It's happened to all of us, okay? So if you are going to be substituting in variables somewhere, I would write this and then solve for the one that you want just to make sure you don't do something silly. Okay. All right, now this is a general result, okay? So this is just a general result that we can now apply to our case 1 and case 2. So let's go ahead and do that. Oh, before I go any further, anybody have questions up till here? This x direction part right here, x direction part. All right, so let's go ahead and plug in. And now I'm going to use what's on my picture again. So for t1, my displacement in the x will be 2x over my vx, which is just vx. Anytime you substitute, everyone look up here for a minute. This will save you at some point on test or otherwise. Anytime you substitute, parentheses, okay? Always, if you're getting rid of t1, put a parentheses and then do the other math around it, okay? A lot of times you can get away with not doing that, and it's fine, but on the times when you can't, it'll mess you up, okay? So always when you substitute in math class, you're technically putting a parentheses and then the square roots and squareds around it, okay? Otherwise, at some point, you will make a mistake if you don't at least think about it like that. And then down here, same thing, except now for this picture. So I'll have my x over vx, because our velocity in the x for both of them was the same. They were launched at the same horizontal velocity, and then squared. Okay? And yeah, I know on this one, yeah, you'll see in a minute. It might have messed you up. There's ones where it's a little bit more of a concern. And the vx squareds, they will cancel. Is that okay? mathematically. And then the x's that are in here, because they're both squared, will also cancel. Is that all right? And then we're just left with what? Anybody? Yeah, 4. Yeah, 2 squared. Yeah, everybody's saying 2 squared. 4, okay? So that's what y1 over y2 equals, 4. So this tells us something. Let's check and make sure that we didn't get it flipped somewhere along the way, okay? So if I solve this for y1, y1 would equal 4 times y2. So that says that y1 is the taller building. And if we go back to my original how I set this up, y1 was the taller building. So it's likely I didn't get it flipped. Questions? Some of you may have looked at this and said twice the velocity. That means it's going to have twice the height. That is not true. It's 4 times the height. That's because when we're setting up which equation we're using, we got t squared, and then we got to link that to the x direction. Again, this result is very specific. This is for 2 objects that are launched horizontally off of buildings of different heights, where one of them is twice the other. Okay, so you don't use this result to answer every question, right? You got to figure it out every time because they'll change things around a little bit. Okay, questions? Yep.
Can you explain how you solved the?
Divided both sides by Vx.
Okay, so it's really the final,
Well, the velocity in the x, this is our free body diagram, right? What's my acceleration left to right? 0. So my velocity in the x will stay the same. The whole time it's just steadily moving to the right. So both objects do this in the y direction. They're dropped. Both objects in the x direction, steadily to the right and at the same speed. Is that okay? All right. And then I just rearranged. So this just came from acceleration equals 0. And if you look at the motion equations, like pick the second one. If you put in a equals 0, you'll get x equals vt. This one, you'll get v final equals v initial. This one, you'll get v final equals v initial. If your acceleration is 0, your velocity stays the same. Is that okay? But the second one can get you that result. Now, I didn't call it v initial or v final. I was emphasizing by just writing vx that it stayed the same. In the x direction. The y direction, they change.
Okay. So those two, like the v or the second line, are like the x on the right. Yeah. Are those like the x? That's the x relationship that you put into the y relation?
Yeah, so I was substituting in for time, displacement in the x divided by velocity in the x.
Okay.
So this is going to be true for any time you have an acceleration of 0. This is true, okay? For any problem, not just free fall. So then I used that for my picture 1 right here. So it was 2x over vx, parentheses squared, because the t was squared. And then down here, it was x over vx, parentheses squared. Is that okay? All right. Other questions? Going once, going twice. I will put it onto OneNote so that you guys will have it. Anybody need a re-explanation on how I picked this or anything, or what was going on here? Going once, going twice. This was just a bunch of math now at this point, except for that substitution. All right, so let me go ahead and stop the video. That was a brief one. If it recorded, we'll see. Yep, it was still recording, 13 minutes.